Hello everyone, so this lesson is going to focus on airfoils, different airfoil parts, how we create lift in an airfoil, and also how we identify the surface area as well as the aspect ratio of a wing. So go ahead and get out your engineering notebook and let's get started.
This is lesson 1.2.6 and focuses on airfoils. In this lesson, you will be able to determine the relationship between airfoil shape and the coefficient of lift and drag. So an airfoil is any surface that provides aerodynamic force through interaction with moving air. In the image to the right, you see an example of someone sticking their hand out a moving car window. When you do this, you can not only feel the aerodynamic force of lift, but your hand acts as the airfoil as it cuts through the moving air. Taking a closer look at airfoil lift, if we look at a section of a 3D wing, so right here, or the cross view of a wing, we are looking at lift as it goes from the direction of flight and the air comes in contact with the airfoil. You'll note that the airfoil is the edge of a wing. So let's look at some aircraft airfoils components. So first let's take a look at the leading edge. The leading edge is the point of first contact between the airfoil and moving air. It's located here on the front of the airfoil surface. Next, we have the chord line, which is an imaginary line that's drawn between the leading edge up here and the trailing edge at the back. So it literally is a line that bisects the airfoil as we come across. The next component we're going to look at is camber. Now we have upper camber and lower camber, and they are the curve of the upper and lower surfaces of the airfoil. These determine the airflow velocity on the upper and lower wing surfaces. We have a mean camber line that goes above the chord line or kind of parallel to the chord line. And then we have our lower camber and our upper camber. So let's take a look at some of these other airfoil components again. Here we have the upper and lower camber, as we just saw with the mean camber line. Our chord line bisects the airfoil from the leading edge and the trailing edge. The leading edge is the point of contact for our relative wind, and the angle at which the airfoil goes into that relative wind is called the angle of attack. So let's look at the design components of an airfoil. First, we're going to talk about the planform, which is the top and bottom view of an airfoil shape. The two shapes you see here are elliptical and straight. In addition to those shapes, we also have tapered. We can also have swept back planforms or delta planforms. Now let's talk about aspect ratio. Aspect ratio is the ratio of wingspan to the average chord width. The higher our aspect ratio is, the higher the lifting efficiency we have in the wing. We can calculate aspect ratio by putting the span over the average chord width. In our example here, we have a 36-foot span and a 5-foot average chord width. If we divide 36 by 5, we are left with 7.2. And if we look at the planform of this aircraft, it is a tapered aircraft. Here's another example. In this case, we still have a tapered aircraft, but we have a 2-foot average chord and a 50-foot span. That's giving us an aspect ratio of 25. Take note that the aspect ratio is unitless. So now let's look at wing area. Wing area is the total surface area of the wing, and we calculate it by multiplying the span by the average chord width. In this example, we have a 2-foot average chord width and a 50-foot span. That means that we have 100 square feet in our wing surface area.
Okay, everyone, that wraps up our airfoil lesson. Please make sure you have those notes ready for class on Thursday. You are going to need them, as this is going to transition us into our airfoil project as well as an airfoil simulation activity. All right, I'll see you in class. Bye.